A few things to remember before we get into solving actual quadratics is this image right here. Does this image look familiar to you? Ish. Do y'all remember learning about this?
Yes.
Okay, what this is reminding you is that if you have the inequalities greater than or less than, notice that they do not have the line underneath them. What kind of closure do they have? Do they have a parentheses or a bracket? A parentheses. So we're going to be writing what's called set notation again today. That means that we're going to be used the parentheses for less than or greater than. If your symbol has the line underneath it, are we going to use the parentheses? No, we're going to use a bracket. Additionally, whenever we have the open circle, that's for the symbols that do not have the line underneath them. And when we have a closed circle, that's for the symbols that have the line underneath them. Okay, so that's something back from like September that we learned that I just want you to remember because we're going to be using that today. But the main gist of today is to be able to solve these quadratic inequalities graphically. So let's remember what inequalities are. What does the symbol greater than look like? Does it look like your right hand or your left hand? It looks like your right hand. So if you put your right hand down on your paper and tilt it to the side, it's going to create this symbol. Now, if you're going to use the same color code as me today, I'm going to do all of my greater thans in green. So pick a color to be your greater thans and stick with that all day. Graphically, what that means is we are looking for where the equation is simply above or greater than the x-axis. So above the x-axis, because greater is above. Makes sense. Okay, great. What does the less than symbol look like? Left hand or right hand? Left hand. Left hand is less than. All we're going to be looking for on a graph is the interval where the graph is below the x-axis. Equal to is not technically an inequality symbol because it's an equality symbol. So obviously today you're looking for the equal to sign whenever you're looking for equal to. And what we're looking for whenever we have equals is exactly on the x-axis. If we have the symbol greater than or equal to, it's like we're combining my green symbol and my blue symbol, which is exactly how I'm going to write it. Greater than or equal to. This means graphically, what I'm looking for is where the graph shows up above or on the x-axis. So we have two options there, above or on the x-axis. And less than or equal to is just kind of the opposite because it's both the less than symbol and the equal to symbol combined. That means we're looking on a graph where the graph itself is above or on the x-axis. So it's all about the x-axis today, and it really makes a lot of sense. For greater than, we're looking for where the graph is up above or above ground if the x-axis is the ground. And if we're looking for it's less than, you're looking for where it's below ground or below the x-axis. And we're going to color code a lot of stuff today. Because when we answer these questions, it's going to very much help for us to have the ideas of above, below color coded. So let's use these ideas to answer the following questions. We want to use the graph of f of x equal to x plus 3 times x minus 2, meaning if they don't give it to you, you can graph it on your calculator, to answer the following questions. Okay, we want to know where the graph is above 0, below 0, equal to 0, above and equal to 0, and below and equal to 0. We're going to do them piece by piece though. It's going to be very helpful for us to also color code our graph. If you notice, this quadratic is above the x-axis here, equal to the x-axis there, below, equal, and then above again. Do we see that? So we have two sections where the graph is above the x-axis. We have two dots where the graph is below the x-axis. And we have one section where it's below the x-axis again. All we have to do is use interval notation to describe the domain or the x values where that happens. So if we want to describe the x values where f of x is greater than 0, so the first one right here, we're looking for the x values from negative infinity to infinity where the graph is green. If I start coloring in this number line right here, is it green or red? What do I mean by that? Yeah, it is green. What do I mean by it being green? It's on the, so I'm looking at the x-axis. Where's the line right here? Is it above or below? Above. And for me, that means green. So I'm going to color in this x-axis green. At that coordinate point, I'm going to put a blue dot. Blue dot. What color should I color this little section of the x-axis? What color is the line at that point? Red. So that section right there is a red section. These are the red numbers because that's where my graph is below the x-axis. Then I have another coordinate point. That's blue. What color should this last little part be? Green. Because again, that's where the graph is above. This is going to super help me answer the interval notation for where the graph is above, equal to, or below. Okay? If I was answering the question, where is f of x greater than 0? I want to answer the x values that are green. What's the first x value that's on the green part of the x-axis? I'm pointing at it. Negative infinity. So I'm going to open a parentheses and I'm going to say this starts at negative infinity. Okay, when does it stop being green? Oh, wait, doesn't it stop right here? What number is that? -3. It stops being green at -3 because -3 is a blue dot. Okay, so I'm going to say this goes from negative infinity to -3 and then it stops. Does it get green again? Starting at what number? 2. So we're going to say also there is a interval from 2 all the way to what number? Infinity, where it is also green. Now in this notation, if you want to answer two intervals like we have, where there's two parts, you're going to put what's called a union symbol in between them. It's just a giant U. It stands for the word union. It's like the word or in math. So it is green, or it is above 0 from negative infinity to -3, or from 2 to infinity. Both of those options are where it's green. Okay, the next question, f of x less than 0, is asking where is the graph red? What's the first number it shows up red? -3. What's the last number it shows up red? 2. Do you notice something about the numbers I just put in that interval? Do they look familiar for some reason? Yeah, these are all the same numbers, right? That's because that's when it switches colors, so they should be part of my interval. Okay, the third question says, where is f of x equal to 0? That's just 2 points, right? What are the two numbers where x is equal to 0? -3 and +2. Those are the two places where the graph is exactly equal to the x-axis, where it's touching or on the x-axis. Okay, here's where it gets wild. The next one says above or equal to 0. What two colors have I included in that symbol? Green and blue, which means I want to answer my interval with the green color and the blue color. Okay, so let me do that. If I look at my x-axis, I would say it starts being green at negative infinity. Same idea. When does it stop being green? -3. But -3 is blue, is it not? Which means that this is going to change to a bracket. The bracket means that it's touching it. We used a parentheses a second ago because we could not include the blue dot. But now that we're saying it can also be equal to -3, we change that parentheses to a bracket. So it's blue. Is there another section where it's green or blue? Yeah, what does it start with? 2, but that 2 is what color? Blue, so I'm going to give it a blue bracket. When does it stop being green? Infinity. And what should I put in between those two intervals? The U for union. What's the difference between the first thing we asked and this last thing that we answered? It's the only difference between this one and this one.
The brackets?
The brackets. For just greater than, you don't have brackets. For greater than or equal to, you add the brackets. That's truly the only difference because now we're able to be exactly equal to -3 and -2. Okay, so with that same idea, how would that change this last one? F of x less than or equal to 0. Where is this graph less than 0? All the way to what number? But both of those numbers are what color? Blue. -3 and 2 are both blue numbers, and if I can include the blue part, what am I going to surround these by? Parentheses or brackets? Brackets. So the idea of solving inequalities is not hard. Above, below, on. The notation is confusing. The notation has so many details that we have to get right. Let me walk you back through what we did on this one before we try another example, because I think hearing it after having it written down will be helpful. Okay, so what we did was we looked at our graph for where it was above. Here's where it's above. Equal to and below the x-axis. Visually, does that make sense to you? Above, below, equal. Okay. To write down the answers, we talk about the x values or the intervals where that's happening. It's green starting from -infinity going up to -3. Then we would pick up our pencil, because it's not green anymore, put it back down immediately after 2, and keep going to infinity. That's what this interval means. Starting at -infinity, going to -3, picking up my pencil, putting it right back down after 2, and going to infinity. For where it's less than, we just want the other side of that interval, the inside of the interval, from -3 to 2. Just between these two things. Where it's exactly equal to 0 is where the dots are. Easy peasy. And for the last one, the last two, we're just combining the first two questions with the brackets because now it can be equal to. So you add the brackets here in the middle and you add the brackets on the outside because now it's equal to those numbers. Okay, stay with me. We're going to do one more example together and then you'll try one on your own. Flip this thing. This is probably the helpful thing to look at as you're doing this. So make sure you have this idea of above, below, and on for the symbols there. Open. Because that's all that these questions are. If we can answer this sort of question, then we're golden for today. Let's color code our graph first. Okay, if I look at that first arrow, based on my color code that I was using, what color am I going to start coloring this arrow? Red, because it's below the x-axis. Very good. Okay, so it's going to be red, and then all of a sudden what happens? Change to blue. Got one little dot of blue. And then what? Green, because it's above. And then what? Blue again. And then what? Red. So this time, I'm going to have two intervals that are less than 0 and one interval that's greater than 0. I like still coloring in my x-axis because I find that really helpful, so we're going to do that again. If I start here at -infinity, what color should I be coloring the x number line? Is it green down here where the line is? No, what color is that? Red. Because the graph is going down, it's end behavior going to -infinity, that part right there is going to be red. Because that side of the graph is underneath. And then right at the number 1, I'm going to have a blue dot.
So
Basically, if the arrows are facing down, your x arrows should be red. If the arrows for the graph are facing up, your x arrows would probably be green. After the little blue, what color should I color the inside interval? Green, because that's the green part, matches the green part. And then switch to blue for the dot. And then switch to red to finish it out and go to positive infinity. Okay, now we just need to get the notation right. We can see visually where it's above, below, equal. We have to describe or communicate properly how it's above, below, or equal. For this one, the first one says f of x greater than 0. Which color am I looking for greater than 0? What color?
Green.
Green. We just want to describe the green interval. Where does the green part start? 1. Do I include 1? Do I put the bracket around it? Or do I put a parentheses? Parentheses, because it's just the less than. Remember, those two symbols have parentheses. Where does it stop being green? 5. With a parenthesis. That's the interval from 1 to 5 where the graph is green. The next question says, where is f of x less than 0? What color am I looking for there? Red. Where does this x-axis start getting red? Negative infinity. Where does it stop? 1. Where does it start again? 5. And where does it stop? Infinity. Now, since I have two intervals there, what do I put in between them? The U for union. It means the word or. It means both of these are fine to use. Okay. I'm going to have to kind of zoom out to get everything on here, so I'm sorry the display is not going to be great. Where is f of x equal to 0? And there are two places where x is equal to 0, like Robert said, 1 and 5. Now the third one, the symbol now has the line underneath it. Symbols with the line underneath it should have brackets. Should have brackets. So that first one is asking where is the graph greater than or equal to 0, which means I'm looking for where it's green or blue. It starts being green at number 1, but it is also blue at number 1. So I'm going to change that parenthesis to a bracket. It stops being green at the number 5, but 5 is also a blue number. So I'm going to give it a bracket because it's exactly equal to 0 there. It's touching the x-axis. So now it gets a bracket. The last one is asking me for where it's less than or equal to 0. So all I really do is take the less than inequality I have, but instead of parentheses on the inside, what am I making those? Brackets. Yes, very good. Because now I can look at where it's equal to 0, and it is equal to 0 at 1 and 5. So anytime you write down 1 or 5, when it's equal to, you put the bracket instead. Okay, like I said, the idea of above, below, we can visually see it very, very simply. The notation is difficult because there's details. But I want you guys to do this last problem together with me, well, on your own, and we'll go back over it together afterwards. So start with color coding this graph. However you're color coding, make it make sense to you, and then answer all of the questions. I'll give you about 3 minutes. Do you think that's enough? 3 minutes. Okay, I'm going to go a little quick through it because you have it down on your paper. Here's how I would have color-coded this. I would have had green, and then blue, and then red, and then blue, and then green, which means my x-axis, starting at infinity, negative infinity, going to infinity, would be green for the green section. Then I have a blue dot. Then I have a red section. Then I have a blue dot. And then I have a green section. Okay, Does our color coding look familiar to you? Okay, to answer these, here's what it would be. The graph is greater than 0 from negative infinity to negative 1 and from 4 to infinity. Pause. Do we need to edit something on our papers? Oh, no. What happened? Let's talk about it. Oh, so that's where it's below. Yeah. Yeah, we all flipped it. So remember, you have to look at the symbol. This symbol is asking for where it's greater than 0. Greater means above. The next one is the one that means below. This one should be the one that goes from negative 1 to 4. Did we just get those flip-flopped?
Yeah.
Yeah, okay, so make sure you're looking at those symbols for greater and less than. Did you put the U for union between them? That's important. That's part of it. Don't just put two coordinates next to each other. That's not a thing. You have to make it an interval putting union in between them. The place where it's equal to 0 would be x equal to negative 1 and 4. Did we get that one?
Yes.
Phew, we know our solutions to quadratics. Great. The next one, since it's asking for where it's greater than or equal to, it should look like this, which means some of us might need to flip-flop it again. Negative infinity to negative 1, bracket, union, bracket, 4 to infinity. Did we flip-flop this one as well?
Yep.
No.
Oh, no. Yeah, you got to check those symbols. It's greater than, so that's the green stuff, where it's greater than. And then the last little bit, where it's less than or equal to 0, we want red and blue combined together, which means I would have bracket, negative 1 to 4, bracket. Woo-wee. How do we feel? Just flip-flopped them?
Yeah.
That's okay. That's why we're learning. We can make mistakes right now. That's why God made erasers. Okay, great. That's all we're going to be doing for notes because that's the entire concept of inequalities with quadratics. We're just looking for linearly where it's above, or graphically, sorry, where it's above or below the x-axis. Yes? You have this classwork assignment that you picked up when you walked in. Notice that each of these only asks one question, not the 5 that I've been asking. So in this first one that goes with the first graph, is it asking for where it's above or below the x-axis? Wait, really? This symbol right here means above? Oh, it looks like my left hand is below. This is less than. So I only want to answer exactly where it's below the x-axis. Okay, so you only have one question for each of these. This is classwork to be turned in before you leave today. This is going in the grade book, so it should be a 100 in the grade book. You can work with a partner as long as you are learning. You have people to ask questions with. You have me to ask questions with. Please do not leave without fully understanding the concept of quadratic inequalities. That's a good question. So his question was, if this was the question to ask for 5 things, the places where the graph is above is just here. Like visually where it's above the x-axis.
Like where would you work on the number line?
Like
Where
the...
should you start and
Oh, okay. That's a good question. So we always want to start looking at negative infinity, which means we're going to the furthest left of the number line. If I were just to look along this number line, what's the first color I run into? Green, which means this section of the number line would be green. And then we have the blue part. And then we have the red part.
I just know that's what I did in my notes.
Yeah. If it's a graph that's a happy parabola, it's going to start with green. And if it's a graph that's a sad parabola, it's going to start with red. That's another way to think about it.
Wait, so what is it? You said happy?
Happy starts with green because it's all above. Unless the graph doesn't even reach above. No, it would have to reach above. Sad parabolas start with red because their graph is below the x-axis. Those are great questions. Okay, you have the rest of the class to work on this. So let's get to solving some inequalities.